Okay, in these next three examples, we're going to find the inverse of a table, list of ordered pairs, and a map. So all you got to do is you take your original table, you take your x and y values, and you just you swap their places. So let's do this first example. Find the inverse of this table. So first column x, second column will be y inverse, and then we just, the -3, 2, we just swap places. So 2 would go in the x column, -3 will go in the y column. So I'll continue to write, swap the columns, just like so. All right. How can you tell from the table if a relation represents a function? What we want to look at is if there's any repeating x values. So if I look at the original table, it asks, does the original table represent a function? Well, the original table is referring to the table of the y. It does represent a function, so yes. Okay, because none of the x values repeat. Now, if you look at the inverse table, when they're talking about inverse, they're talking about y to the -1. All right, so y inverse. If we look at our x values, we got 2 repeating x values, which is 2. So what that means is that 2 has 2 y values, and that is not the definition of function, where every x value has exactly 1 y value. So in this case, 2 has a y value of -3 and 4. So this is not a function. Okay. Looking at a list of ordered pairs, same concept. We're just going to switch their places. So if you remember your ordered pairs, they all have x, y's, right? Put 2 x's there. Y, x, y. All right, so we'll call this list y. Let's take the inverse list. So y inverse, make a set. So we'll flip it around. We'll put 3, 2. Okay, so just swap the y and the x part. Okay, 8 and -5, and 3, 7, and -6, and 9. Close the set. Okay, so does the original list, again, talking about the y, of pairs represents a function. So just look at the x values, 2, -5, 7, 9, no repeaters. So that does make it a function. All right, does the inverse of the list pair represent a function? So the inverse, y inverse, y to -1. So no, it doesn't, because we got the 3x value there and the 3x value there. So no, that does not represent a function. Okay, so this one here is called a mapping, and what we do is you just kind of follow the arrows. So we can make a table, just like so, and 0 goes to -1, and 0 also goes to 0. Okay, and then 5 goes to 0. So we can make our inverse table. Just swap them around. -1, 0, 0, 0, 3, and 5. Okay. Is the inverse a function? Well, when talking about that, again, y -1, which is that table there, and it is, because none of the x values repeat.